verified inference is beyond what anyone in the industry does today from an IT standpoint. So that is a fundamental step forward, and I think a necessary one. Otherwise, you end up in the position that you're talking about, where it's a race to the bottom with
Correct.
opaque infrastructure providers who have misaligned incentives. So that's a huge step of verified inference. But then you can't stop there, obviously. And I think that there are a number of components that you can build on top that are helpful. And of course, as always, it depends on what your goals are. If you're writing a role-playing game engine, then factual correctness may be less important to you than in other applications like engineering applications, because perhaps lack of factual correctness is the entire point. You're imagining something. But
Right.
for these types of business or agentic applications that have economic import, I would say some things are very important. So one of those is part of the guarantee that we're baking into verified inference, which is understanding the context that we're engineering into our question. So these artificial intelligences have limited capacity. You could think of it like short-term and long-term memory, just like people have. They have a limited capacity to understand the world and situations based on the amount of information you throw at them at one time. And so you need a robust system that is feeding these systems relevant context. Verified inference provides you a guarantee that, in fact, the context that you engineer is what the model acts on. So that's fundamental. But you also need really good context selection systems. So, what do those entail? There are a lot of them around. At a very high level, you could say that they all have to do with memory and salience. So when I talk about salience, that is like relevance. It's the degree to which any piece of information applies to the problem that is being solved or the question that is being answered. So
Right.
Salience and memory can be gauged in different ways. Salience often has to do with novelty. So you might have a lot of information that is the same and one piece that is different, and salience lets you find the needle in the haystack. This is the basis of many tests of agentic memory. So that's one strategy. Another strategy is associativity. So we use vector databases, and we look at the neural representations associated with text, paragraphs of text, sentences, maybe pages of text. And we look at the similarity between those neural representations and other neural representations. And we pull in context based on similarity scores. So, for example, if you're writing an essay about war and peace, and you have some PDF references that are reviews of that book, then those are more likely to be pulled in to your context than, for example, references to comic books from the 1950s. It's just semantic similarity. So, and there are also ways that you want to learn from the behavior of your users. They may give you feedback that certain references in certain contexts are less relevant than others. And so you actually want your search and context system to be able to respond to users and adapt to their preferences. So that's one whole box of scaffolding that you need for what we would call, maybe factually verified inference. And the reason is that what that allows you to do is pull in context that you trust to give to the LLM to answer questions factually. A typical example of this would be your company has a series of policies and procedures, and you want a customer service agent to be able to quickly query those and respond to a customer based on maybe a relatively complex situation. Just pull up the relevant things, and then the LLM sort of tells you how you might answer.
Okay.
That is possible because of sophisticated context engineering. Okay, so we're going to say this is one type of system. But then there's another type of system, which is search, what we often call deep research. And that involves cases where the local context that you have is insufficient to guarantee a factual answer to a query. Maybe your company manual only covers a certain class of machines that your company has produced over the last 5 years, but maybe there was a merger and acquisition 10 years ago, and there's a bunch of PDF documentation on older machines that you need to reference. Well, then your agent needs to be able to go out and search and find that additional context. And it's not just a matter of what search engines do, in the sense that it's not just about pulling links and ingesting those blindly. It's also about the model making a judgment about the validity of that information.
Okay.
For example, if that PDF manual appeared on a site that had a bunch of obviously false content, you would want to score that less than if the PDF appeared on a site that only contained relevant technical content. So that's another piece of scaffolding that you need to build. There's a third piece of scaffolding. It's a category of scaffolding, which is related to the boundaries of your system and its span of control. To give a simple example, an AI agent that has access to your customer records should not be able to drop a table in the database and delete a large number of customer records. It should actually be impossible. And so you have to build programmable safeguards in that allow fine-grained control of what an agent can do.